Hello everyone. In this second video on ANSYS and finite element analysis, we are going to talk about sketching in ANSYS Workbench. Before I start the video, just wanted to mention, if you go to my channel under FEA and ANSYS playlist, I added the references for my videos. The first one is Finite Element Simulation with ANSYS Workbench 21 by Hui Huang Li. And the other one is Finite Element Analysis, Theory and Applications with ANSYS by Saeed Moaveni. So these are some of the very textbooks that I found on the theory and on the application with ANSYS. The first one has a lot of good figures and a lot of clarifications step by step. So it's a self-read book, and it tells you step by step how to go from one task to the next. It has numbered all of the tasks, so you do first task 1, then go 2, 3. It's an amazing book by SDC Publication, a lot of good pictures. And this textbook is amazing when it comes to theory of finite element analysis. So I absolutely recommend taking a look at these two amazing textbooks. So here we are in ANSYS Workbench, and you can just, if you want, create a geometry, or if you want, you can create a geometry to do static structural analysis, right? So if you just want to create a geometry, right, you can go ahead to this component systems and you can look for the geometry, which is here, right, and grab it. And this one allows you to just create the geometry. So you right click here and then go to the Design Modeler, and you can create your geometry. The two geometries I'm going to do for you today, one is the profile of the I-beam here, and the other one is this kind of you might call it a plate planar object that is kind of triangular with a bunch of fillets with a hole in it. And the first one has dimensions in inches, the second one has dimensions in millimeters, and they're both coming from my first reference textbook. So here, if we go into the modeler, here we have our three planes, x, y, y, x, z, and y, z, and this is our triad. If you click on any of these axes, you can go to the plane that is perpendicular to the axis. So if you want to go to the xy plane, click on the z-axis. So now you are in xy plane. If you want to go back to the isometric view, click on this guy here, this is small sphere, right? You go back to isometric view. If you want to go to zy plane, click on the x-axis, and so on and so forth, right? Or you can, for example, click on the xy plane and then click this guy which says look at face plane sketch. And then you can also go back to the xy plane. So once you are in the xy plane, now here you see I have the modeling tab which has the tree, and then I have the sketching tab. So click on the sketching tab now that you are in the xy plane. And here, these are the drawing elements, right? Line, polyline, polygon. If you click on this and go down, rectangle, oval, circle, all sorts of things, 3-point arc, S-spline, ellipse. If you go to modify, these are your trimming elements, fillet element, chamfer, extend, you name it, right? Cut, paste, move, replicate, duplicate, offset. Here you have your dimensions, all sorts of different dimensions, and the geometric constraints to make your sketch fully defined, right? And then here you have setting. For example, if you want to see the grid, you click on the grid, right? And then say show it in 2D. If you turn on a snap to point, then you can only click on the grid points. If you want to be able to click anywhere, whether grid points or between the grid points, don't turn this snap to point on. So here I turn the grid on, but don't turn on the snap. So I can click anywhere I want. Now, if I want to create this basically eye profile, there are two ways I can do it. One is I draw the total eye profile, right? And using a polyline, and then I later add these fillets and provide dimensions. The other one is I make a rectangle and then basically, right? So I make a rectangle like this, and then I draw these polylines. So I go one line like this, and then the other one like that, and another one, and then I start trimming, right? Or subtracting, basically. So there are all sorts of different ways that you can do it, but here I try to start with my eye profile with the polyline and provide the dimensions. And the other thing is, you see the units here, they are meters and degrees, but I need it to be in inches. So I go up to units and I change my dimensions to inches. And you see the grid does change too. By the way, the controls from your mouse, if you scroll, you can zoom in and zoom out, right? If you hold down the scroll and drag, then you can rotate. And if you hold, if you just hold down the scroll and rotate and drag, that's rotation. If you hold down the control and the middle mouse and drag, now you can what? You can pan it. And you also have pan and what? Rotation up here for you. And there are other things, like here you have the box zoom that you can zoom into a specific area. Here is zoom to fit if you want to do appropriate fit, and this is your zoom button. And here this guy will give you back to isometric. Okay, so there are lots of buttons here that we're going to go through. There are the selection filters here that we're going to talk about, and so on and so forth. So let's go ahead and go to the draw and create the polyline. So line draws a single line, but polyline draws connected lines. So here I start on polyline, and then I start drawing my first top line. Now here you see when the line becomes horizontal, you see that H on the top of the line indicating that my line is horizontal. Then you see here V stands for vertical, so I'm vertical. I do another horizontal, I do a vertical, and keep going. And this is unlike SolidWorks. When you get to a point right down here that is vertically aligned with this corner, you're not going to get any dash line indicating that you are vertically arranged with it. So do not expect any smart constraint here. Just keep drawing, okay? So here, I keep drawing. As long as you can have them vertical and horizontal, that should be enough. You have to do the rest manually. So here we go. Now here, when you get to the end of it, again, since you don't have the smart constraint, you don't know where to stop. So you just stop anywhere. And when you go here to the first corner points, you see it doesn't show a coincidence, right? Ideally, it should show the letter P, which stands for coincidence, but it doesn't. And when you click here, right, on any point, you might not necessarily make the profile closed, right? Because you might click a little bit above it, below it, or anything for that matter, right? So you might not exactly end up making it coincident, unless when you click here, then you see right click, and then instead of open end, which means leave the profile open, you say close it. This way you are sure that here there is a coincidence here. So you right click and say close end. Now if I zoom in over there, you see it's not perfect, right? It closed it for me, but at the cost of what? At the cost of adding this extra line here. So I can always go ahead and delete that and then see if I can, let me go back and then see if you can fix it. So let me try to see if I can do a better job this time by having one line instead of two. So here, hopefully, yeah, this one is closed now. You can see I use the simple line, and that square over there is indicating a coincidence. So yeah, I do have a coincidence here. But what's the problem? This last line that I made is not vertical, but I can force it to be vertical. I go to constraints, right? Let me click on my select. Okay, so I go to constraint, I choose vertical, and then I select this guy, right? And you see it immediately made it vertical. So at least now I have something that looks right. Now, what are the dimensions? So 7.07 and 1625. So I go to dimensions, I choose general. This guy is 7.07. And this one as well. So when you create them, their dimensions show here on the left side as H1 and H2. They have a name and you can modify their dimensions. Now here, when I want to provide the vertical distance between this edge and this edge, I choose this vertical dimension. So I go here, here, and then this guy was 1625. So here we type the dimension, right? And you see, of course, it is going to change the sketch, but that's okay. The thickness is 0.628. So let's go ahead and apply this 0.628 everywhere. So here I applied this 0.628 to all of the sides of the flange. Now the thickness of the web in the middle is 0.38. So here that's a horizontal distance between the two. So I apply that here, right? And now, so the thing left is this fillet radius at these four corners, and it's better to make it symmetric about the axes. And to make it symmetric about the X and Y axis, I can either use dimensions or I can use the symmetry constraint. So here I go to constraint and I go to symmetry, and then I would select the axis of symmetry, which is this guy, and then the entities that need to be symmetric about it. So here you see those two lines are applied now, so I'm good. The next thing I want to apply is the two sides of the web. So again, I select this, then I select this one, and then I select this. There we go, right? And then I go to the bottom portion and repeat it for the two sides of the web. So again, select this one, select this one, right? And then I can repeat that for the y-axis, or the x-axis, I'm sorry. So here I select this axis, and then come down, and then choose this, then choose that one. And now if you look at your sketch, it's completely blue color. There is nothing that is bright blue, it's all, or navy blue, it's all dark blue, and that means the sketch is fully defined. Also, if you want to move some dimensions, you cannot just grab them and drag it elsewhere. You have to go under dimensions and click on the move command, right? Now you can grab them and move them to somewhere else. So keep that in mind, that in ANSYS, it's a little bit different than SolidWorks, and you cannot just simply grab a dimension and relocate it. You have to use the move dimension command if you want to do it. So now we go to modify and we go to fillet, and remember the radius is 0.375, and we are going to apply that to these four corners to avoid the stress concentration. So before anything, I would type the radius here. Now I'm going to apply it on these four corners. So now I have the sketch all defined. I can make it 2D objects or 3D objects, right? If I want, I can go to extrude and then extrude the whole sketch, right? So if I go to 3D, you see, now I can extrude it for as much as I want, let's say 50 inches, 60 inches or so, right? And once I say generate, it is going to generate the I-beam for me, right? And you can see it under here. Or if I don't want it, I can go to here under concept and say create surfaces from the sketch, And then I choose this sketch and I apply that, right? And then I say generate, and now as you can see, I have a 2D surface like that. So this is my first object, and now I'm going to go over this second one here. Okay, now we are going to do the second sketch, and for the second one, what we are going to do is basically we are going to use trimming tools. So what I'm going to do is to draw 3 lines to be something like a line like this. Sorry. Let me bring it down. Something like that. And then another one like this. You see these corners? So we are going to connect those corners together and make a triangle. And then we're going to draw 3 arcs that you can see here, here, and here, and their centers are these 3 corners of the triangle. And then we're going to use trimming tool to create the basically the outside of this shape. So first I'm going to draw my triangle, right? So here we go. I go to XY plane, create a new sketch, and then go to sketching, and then go to the polygon command and try to start on the x-axis. You see that C means coincident, and then go here, then go down vertically, then go back on the same point and make sure it is close end, right? As you can see, always check it, always make sure that it is what you intended for it. As you can see here, you are really 1 point. And now you need to provide the dimensions, which is 2 and 300, and they are in mils. So first go ahead and change your unit to mils, and then provide the dimensions 200 and 300, which are horizontal dimensions. So one is this guy here, right, and the other one is this total dimension here, which is 300. So it's going to be between this one and that one, and this one is supposed to be 300. The other thing we need to do is to make sure it's an it's a triangle with all sides equal, equilateral. So here we have to apply the equal constraint. So we go to constraint and we go down to equal length, and then we choose this one and this one. And then we choose this one and this one. And so now it's an equilateral. All dimensions match. So now, as I said, it's time to draw these 3 arcs, and make sure that when you draw the arcs and trim, the size of these 3 flat sides that are left are 40 mils. So now we go to draw, and then we draw the 3-point arc, right, by 3 points or by center. Since here we have the centers, so we use this one, and here this is our center, and then we have a point here, and then we draw it to here. And again, make sure the C appears to show that the endpoints are coincident with the lines, and then repeat that for the other 2 corners. So now it is time to do the trimming. So I use my trim tool and I get rid of the portions that I do not need. So here these guys have to go. And there we go, we got them. Now the dimension of this thing here is 40. So we are going to limit it to 40. Then we'll try to do a similar thing to the other ones, or we can use the equal again. So it is up to us to choose how you want to define it. Now, the problem is this. You see, the way that I did this, it is completely ruining your sketch. So the order sometimes might be important, and the other thing is symmetry also, because when I deleted those corners, some of the symmetries are gone. So before you apply dimensions, maybe you want to make some stuff symmetric. So here, if I go under constraints and apply the symmetry first, then I do the dimensions, I'm not going to lose my sketch the way it was. So I select here and then here and then here. You see, now I have the symmetry. So hopefully, if this time I go and change that 170 to 40, you see, now it's not ruining my sketch. Then I can do under constraint the equal, right, length, and make sure this one and this one are equal, and then this one and this one are equal. There we go. So now this sketch is in a good shape, right? Now you might need to apply a dimension of radius to one of these arcs, like this one, which is determined already, but that helps you make this whole thing fully defined. And as I said, you can go to dimensions and move them around if you have to make your sketch a little bit better organized. Okay, so now this sketch is done, and now it's time to make this hole inside it, which is, again, if you look, it's a triangle, equilateral triangle, but it has fillets of radius 10 at the corners. So we are going to do that, and first draw the triangle and fully define it, then apply the fillet of 10, and for that we also need this dimension of 30. So here we go to the polyline again, and we draw the equilateral triangle. So here it is. We make sure that this line is vertical, which it is. We can apply equality to them. So this one is the same as this one, and then this one is the same as this one. There we go. Then we provide the horizontal distance, which is from here to here, and this distance, or actually it's to the back of here, right, is to the middle of the arc. That is 30. So let me see if I can do that dimension. So this dimension is redundant. I do horizontal distance if it allows it, yes. This guy should be 30. So now the arc is defined here, but as you can see, it's not fully defined, which I assume it doesn't have the symmetry. So I go to constraint and apply a symmetry first. Make sure with respect to this axis, that corner and that corner are symmetric. Now this is good. And you can apply a dimension to one of the sides, like this. Now you are fully defined, and now you go to the fillets under modify, and then the fillets are all of radius 10. So here we make it 10, and we apply our fillets, and that should create the sketch that I want. Of course, I apply my radius to one of these, right? And you have to apply it to the other ones, but you know the sketch is good. So this is my sketch now, and now if I want, I can go ahead and generate a surface from this, right? So I select that sketch and I apply that, and then I generate it, and clearly you see that I have generated the 2D object. But if I want a thin 3D object that is represented by the 2D object, I can apply some thickness, let's say 2 mil thickness here. Then if I generate that, then this guy is going to be represented by what? By a 3D thin object with a thickness of 2 mils, which will be used for your stress analysis that we're going to do in one of my next videos. So there are too many tools in the sketching. I showed you some of them under constraints, under dimensions, under draw, under modify and setting. And hopefully this video was useful to you. So I will see you in my next video. Thank you.